Okay, in this video we're going to be looking at completing the square, but slightly more advanced this time because we're going to be looking at completing the square where the coefficient of x squared, which we call a, is not equal to 1. So we haven't got x squared plus something or x squared minus something, we have 3x squared or 4x squared or 2x squared. So for example, if we took 2x squared plus 8x minus 7. Now, the way that I'm going to do it with this one is, the first thing I'm going to do is I'm going to take 2 out as a factor. But I'm only going to take that out of the first 2 terms. So I'm going to take 2 out, so we get 2 lots of x squared plus 4x. And I'll leave the minus 7 outside. And then what I'm going to do is I'm going to complete the square on the bit that's inside the brackets. So when I do this, I like to do it at the side. So I'm going to make a little section over here. So if I have x squared plus 4x, technically there's no constant, so technically that's plus 0. So when I complete the square, I have x. I'm going to halve the coefficient, which is plus 2 all squared. I'm going to subtract this value squared, and then I would normally add on the constant that I want, but because the constant is 0, then this is it completed. So if I then put that back into these brackets, this is 2 lots of, okay, so it's x plus 2 all squared minus 4, and then we take off the 7. Now our next job is to expand these brackets, so I have 2 lots of x plus 2 all squared, 2 lots of minus 4 is minus 8, and then the minus 7 is on its own outside the brackets anyway. And then we're going to bring together our number terms at the end, so 2 lots of x plus 2 all squared, minus 8 minus 7 is minus 15. So in terms of what this graph will look like, I'll do a little sketch. Okay, the 2 inside the brackets is going to shift it 2 to the left, so to minus 2. The minus 15 there is going to send it down to minus 15. So this is where the minimum point is going to be. And the 2 in front here, it stretches the y value, so it makes it twice as steep as the normal x squared graph. But because this is a sketch and there's no scale, then we don't actually have to worry about that. So it just comes down and comes back up. So the minimum value is minus 15, and that happens when x is minus 2. In the same way that we did on the previous video, if you're asked for the coordinates of the minimum point, well, the coordinates would be minus 2, minus 15. Okay, so if you try another example, let's try 3x squared minus 2x plus 2. So the first thing I'm going to do is I'm going to take 3 out as a factor, so I get 3 lots of x squared minus, okay, this doesn't go in nicely, so if I divide it by 3 I get 2/3 of x, and then I have a plus 2 at the side. So I'm going to complete the square on the bit in the bracket, so I'm going to make a nice little section over here. So that's x squared minus 2/3 x plus 0. So if I halve the coefficient, half of 2/3 is 1/3, so minus 1/3 all squared. I'm going to subtract the square of this, which is 1/9. Normally I would add the constant, but because that's 0, I don't have to do anything. And then substitute that back in up here. So this is now 3 lots of x minus 1/3 all squared minus 1/9, and then plus 2. And if I multiply through by 3, this gives me 3 lots of x minus 1/3 all squared. 3 lots of minus 1/9 is minus 3/9 or minus 1/3 plus 2. Well, because I'm dealing in thirds, like in the last video, if I write 2 in terms of thirds, well, 1 whole is 3/3, so 2 wholes is 6/3. So overall, this gives us 3 lots of x minus 1/3 all squared minus 1/3 plus 6/3 is plus 5/3. And then similar to over here, you could then sketch a diagram and show where the minimum value was. I'm going to take one more example now of completing the square. If I complete the square of 1 plus 4x minus x squared. Now this is in a slightly different format because we're used to having it in the form ax squared plus bx plus c. So if I rewrite this and put the x squared term first, that's minus x squared plus 4x plus 1. Okay, so the first thing I'm going to do is I don't have 1x squared, I have minus 1x squared, so I'm going to take minus 1 out as a factor. Now I could write minus 1, but minus 1 is the same as just taking a negative out as a factor to leave us with x squared minus 4x, and then I'll keep my plus 1 separate. Okay, so I'm going to complete the square on x squared minus 4x, so again I'm going to do it at the side, so that's x squared minus 4x plus 0, which becomes x minus 2 all squared, and then I'm going to subtract the square of this, so minus 4. So this now becomes the negative of x minus 2 all squared, take away 4, plus 1. So this is the negative of the bracket, so it's minus x minus 2 all squared, minus minus 4 is plus 4, and then the plus 1 at the end. This gives us minus x minus 2 all squared plus 5. Now this time we have a negative x squared graph, so if I sketch this one, then it's going to be an n-shaped curve instead of a u-shaped curve. So it's going to be moved 2 to the right, 5 up. So instead of having a minimum value like we had before, we actually end up having a maximum value. So the maximum value is the highest points that the curve can take. So the maximum value is going to be, goes right the way up here to 5, and that happens when x equals 2. Or we could say the minimum point is, and if we use the coordinates, it's 2, 5. And that's how we do it when the coefficient of x squared is not 1.